Hey everybody, this is Larry. This is day 17 of the August Leetcode Daily Challenge. Hit the like button, hit the subscribe button, join me in Discord, and let me know what you think about this problem. Distribute candies to people. We distribute some number of candies to a row of n equals n people firing away. We give one candy to the first person, two candy to the second person, and so forth. Back to n plus 1, n plus 2, 2 times n, and then repeat. Okay. I think the first thing I would do is see if you could simulate it. It seems like candy is 10 to the 9, so you can't really simulate it that easily. Well, can you? So if you simulate it, it'll probably be roughly be square root of this. So that'll be like 10 to the 5th-ish, so maybe that's okay. But you can actually do it a little bit smarter, I think, by just taking the number of people, and then you could do the math on how many on each iteration. Yeah, and I think I'm going to do that. And yeah, so this problem is just a lot of math, to be honest. So there's not really that it's not really that interesting for me to go over how to come up with it. Basically, the idea is that well, the straight up naive solution is just, okay, let's simulate 1, 2, 3, 4, 5, ... to n, right? And then so forth, and then go forward. And then now we notice that, for example, here, this is just equal to n times n plus 1 over 2 or something like that, right? I always forget if it's n times n plus 1 or n minus 1. I always mix this up with n choose 2, but you get the idea. And then now this is n times or n plus 1, I think, maybe. Yeah, n plus 1 times another 1, 2, 3, 4, 5, 6, you know, ... to n, right? Which is equal to this thing times n plus 1. Yeah, so I think that's kind of the strategy. Oh wait, is this right? Sorry, this is wrong. This is actually this. So if you subtract, I got my math wrong, my bad. But if you subtract n, because this is the first number is going to n plus 1, n plus 2, n plus 3, ... So if you take the n out, it's just going to be there's going to be n of these. So it's just n times n plus this, which is equal to this, the first part, plus n squared, right? And then similarly, then the next one is going to be what, 2n plus 1, 2n plus 1, 2n plus 2, ... and then if you take out the 2n, there's going to be n of these, so it's going to be, you know, this, so ... So you kind of get the pattern here, and that's how I would kind of make this speed up by a lot by just using a while loop. Yeah. Am I right? Because this math seems a little bit weird, but maybe not. Because this is... Yeah. This is okay. It just seems so. It feels a little weird because the symmetry isn't here with this, but maybe that's just the way that it goes. Unless I'm wrong. Minus n. No, I guess it's right. But okay. So then now we can just have a while loop, and yeah, no, I'm still a little bit bugged by this asymmetry. But I guess maybe that's because this is times n of these, but it's 0 instead of 1, which... okay. I mean, the asymmetry is a little bit weird, but and in math, sometimes you just think about these things because you're like, well, yeah, okay. But okay, so then now we just have a while loop to kind of keep track, which is, okay, let's just say I don't know, candies used is equal to 0, while candies used plus next level, maybe something like that, is equal is less than or equal to Candies, then we keep on doing it, right? Next level being so the first one would be just level 0, and then yeah, and this is next level times number of people, I guess. Okay, so then now if this is greater than we want this number, I should have converted this to n, but so you have this formula over 2, right? So this is the number of the current level Candies is equal to this number times next level times n, right? Or plus, sorry. Actually, it's this times number of people. Oh, that's why my symmetry. This is actually I reduced this incorrectly. This is actually 2 times n squared. Okay, so now the symmetry makes sense. Okay, see, I think so. There is some there's very often symmetry in math that allows you to kind of do sanity checks, and that's why it was sitting very uneasy with me. And that's now how I can sometimes you make silly mistakes, and that's how it kind of comes out that way. But yeah, so this kind of makes sense. Yeah, okay. And now next level increment plus 1. Yeah. And then, oh yeah, Candies used is current level Candies. So I think there's one more thing that we're missing a little bit, which is that now we have a quick way, because this grows really quickly, as you can imagine, like quadratically. So it'll be on the order of square root times again. But now we have to figure out how many in each candy, right? So let's kind of play around that for a second. So Candies is equal to 0 times number of people, and then okay, do I have a formula now after the number of levels used? So after one level, well, actually, right, this is just the first number is always going to be 1. The second number is always going to be 2. So so we know that the difference. So it's just going to be so for example, for index in range of number of people, and this should go from 1 to number of people. Actually, I guess, but it is a 1 index, and that is just index times next level. It could be maybe off by 1 actually, but because of the way that we do the increment. But and then we have to add in this column, which is the summation of 0n, 1n, 2n, and so forth, right? So then that means it's just, again, n times n, because basically you have 0n, 1n, 2n, so then that is just this times n, right? Because now what you have is a formula that's something like 0n plus well, the contribution for each of these will just be 0 in the first one, n in the second one, 2n in the third one, right? So it'll be 0 plus n plus 2n plus 3n dot dot dot. So that means that this is, if you take the n out, it'll be 0, but plus 1 plus 2 plus 3 is equal to n times n plus 1 over 2, right? So that's kind of the formula for the contribution, depending on the number of next level. So we can play around with that. Then we saw Candies is just equal sub-index is equal to this index thing, but plus 1 times that. And then this number is actually the same for each level, actually, right? Oh, sorry, for each person. So then actually we can just calculate it, which is per person maybe is equal to number of people times number of people times number of people plus 1 over 2. So it's this plus per person. I mean, I know that we didn't figure out the remainder yet, but let's print it out real quick just to kind of test our theory a little bit. Just to kind of get a little bit of a sanity check to see if we're going in a good place. It seems like we're not, because this is way too much, clearly. This is not close, right? So, what did I do wrong? So maybe I think my next level might have been off by 1, because I think I was saying that. Okay, still no. Oh, I messed up because I used n here. I used this n, but this actually is dot plus to the next level, right? So this is actually I just messed up because I used the same notation and confused myself. So something like that. Okay. Because looking at this form, it doesn't really make sense otherwise. But yeah, again, this is just a messy math problem. No need to worry. So okay, still no Gucci. Oh, I have to maybe decrement again. I just didn't, cause now this brings you over, so you probably want decrement. That's my philosophy. I think this is still wrong. This one I think is technically right, but this one is wrong, right? So that's not great. In fact, this is way more. But this is always gonna be a tricky problem with these. So the next level is 2. And right now I'm just doing debugging. But that's why we want to do this before I implement the second part, is so that I can isolate my assumptions correctly, right? And now this here, that's one level, which is correct, but maybe my per person is wrong. Per person is 3. It may be that my next level is off by 1 on my math, because we start from 0, right? So this is actually only goes up to next level minus 1. So that means that we have to move this over. Okay. Hope that's it. It looks better now, but we'll see if the math works out. And we can play around with a big number just to, we have the benefit of knowing the answer, right? So let's just play around with a big number. Let's try, was it 1? Let's just try 1 million for now, and a 5, and then we'll see if we get it in the same range. And I removed the print statement, so that makes it harder to play around with. Though I guess we could just return it, to be honest. And again, we don't expect the correct answer yet, but we want to validate what we believe would be consistent with the answer. And here, and it looks okay actually. This is kind of what we expect. So let's implement the second part, which is now we have candies left over. So candies left over is equal to candies minus candies used. So now we go from, for index in range of number of people, we sell candies of index, we increment by, let's see. So on the next one, we have next level times n candy, so max of that. Okay. So max of next level +1, I think, could be wrong, times n. So max of this and z. So that's the number of candy that we expect to use. Alright, just name it expected is equal to this, but actual is equal to min of candies left over and expected, right? Because if you don't have enough candies, then do that, and then now candies left over minus actual. Okay, so let's print it out. Let's run it again and then take a quick look. Maybe I'm off by 1. Yeah, clearly. Oof. Actually, the signs are just wrong because I didn't have parents. Whoops. Whoopsie daisies. Still wrong. Did I use this incorrectly? Let's print out candies left over. There's a lot of potential for off by 1, so I'm definitely very mindful of it and kind of trying to keep things in a good way. My candies left over is wrong. Do I subtract it in any way? This condition is a little bit weird, maybe. I think this should be here, though now it is a lot more copy and paste. Why did I do that? Okay, so now it looks more okay. Still not actually okay. But let's remove this part so that I can just double check my original thing, because we changed a bit of the loop, right? Oh, definitely messed something up. What was this? Next level times the number of people. No, this is definitely right in what I tried to do. For some reason, maybe I was doing some funky math. As they say, math is hard. So now let's basically essentially remove this part so that we could focus on this again. How did that break? Before it was working or within expectation, but now we have -1 on the next level. No, maybe now I don't. Okay, let me. And this is one of those problems where I have to validate what the hey I'm doing. We had it right before. So there's 7 candies left over out of 7, so that's not great. And also not. No, that's actually correct. And why is this? Because per person is 4. Why is this per person of 4? So if the next level is 1, this should be 0, but okay, fine. Okay, now it's right again. Okay. I guess now because we only checked correctly, so I guess that's okay. But still, obviously, still some issues here. Yeah. Expected should be next level times the number of people. Is that right? Now this as well. This should be, so for the first number it should be 1, and then it should be n plus 1, and then, you know, so it's this plus index, I guess, actually. Plus 1. But then now we, because we don't decrement it, we actually don't need to increment it. Again, a lot of off by 1 issues, but now we're finally at the home stretch. Looks okay. So let's, yeah, really messy code, but let's try at least a big number. And 1000, I guess. I think those are the constraints. Yep. Yeah, 64 seconds. Is that okay? It looks okay. So I mean, if it's good for this case, then I'm confident about it. So let's submit. Unless is it like a weird? Okay, let's just do a 1 case, I suppose. 1. Okay, so all looks good. Let's submit. Cool. Yeah, not bad. Really tricky. Not that tricky, but I think I just had issues with off by 1s with math. But yeah, I think for this problem, as I said, it's in the beginning, it's a math problem. So just make sure you sit down and kind of come up with a quick way to do this, and then everything will kind of come together. But may possibly very slowly. You just have to be sure that every step of the way you're asking the right questions and having the right, you know, bringing down the problem into the correct components so that you're able to check, like have checkpoints to see where they are every step of the way. Yeah, anyway, that's all I have for this problem. Let me know what you think. Hit the like button, hit the subscribe button, and I'll see y'all tomorrow. Bye bye.